Then we will move on to fluid kinematics. What earlier, the things like pressure and other things, they are considered for static fluid mechanics. But then if the fluid is moving, different terms need to be defined and considered. So we shall be considering Lagrangian and Eulerian descriptions. These are the different coordinates that we consider when we have to consider the movement of different fluids. So there are two basic ways that scientists have devised. One was first devised by a famous mathematician Lagrange, and the other one was Euler. Both of them defined their own coordinates, and therefore the phenomena, if we are using Eulerian coordinates, we consider it as Eulerian description, and if we are using Lagrangian coordinates, then it's Lagrangian description. So we shall be looking into that. Acceleration field, of course, if anything is moving, particularly the fluids in this case, they don't move uniformly. They don't move with a constant speed. And therefore, if the speed changes with time, there will be acceleration. So there will be certain area where there will be acceleration, and there may be a certain area where there may be acceleration or there may not be acceleration. So that kind of thing. Then material derivative. What is material derivative? So in all our derivation of equations that governs the motions in fluids, this is a very important consideration point by which we define what is material derivative. Fundamentals of fluid visualization. Fluids or the study of fluids is a highly visual subject, as you can see. So, and it involves a lot of experimentation, verification of results, verification of theoretical results. Therefore, at times we need to verify our results, our theoretical prediction, compared to what happens in real circumstances. And therefore, we need to see the fluid flow. And it is not easy to see, if we want to see a certain area of water flow in water, one can imagine that we cannot see it. We can't see it with the naked eye. So we have to devise a methodology by which we can use. Now there are a number of ways to consider and to see the fluid flow very easily. For example, we can add a dye in a certain area, then that dye will stick to a particle, and as the particle moves, we can see the movement of the fluid, where in which direction it is going, with what speed it is going, and it's easy to see. And the other area, there may be area where the dye will not spread and that will not be affected. Similarly, it depends on case-to-case basis. There may be a number of cases where a dye doesn't work. What do you do? So scientists, very brilliant scientists, have developed intelligent ways of seeing fluid flows. For example, they use wires, electric wires, platinum wires that allow current to pass, and current in a very small quantity is allowed to pass in a way that it is split, that it generates hydrogen bubbles in the fluid field. So the bubbles are very small, but in the liquid of the same color, just the presence of the bubbles and their movement shows how the fluid is moving. This is another technique of seeing how a fluid is moving. So I'm just giving you these examples, but we shall discuss them more in step-by-step manner. Fish scales is another thing. Fish scales are dropped in a certain area of fluid that is flowing, and as those scales are moving, because they move with the speed of the fluid, then the fluid movement can be seen. Similarly, streamlines and stream tubes, we shall be defining them. Then path lines, streak lines, timelines, refractive flow. Then different techniques are applied to different types of flow, surface flow, then visualization techniques, of course, I have mentioned, types of motion or deformation of fluid elements, vorticity and rotation, comparison of two circular flows. So all these consideration we shall be doing in the fluid kinematics, where the fluid is moving, and in fact, as our subject says, it's advanced fluid dynamics. So we will be more concerned with the dynamics of the fluids.